So Git workflows, just making sure that, there you go. All right, so in this section, let's talk a bit about Git workflows. Now this, let's see. So we are trying to understand Git workflows out here. We're not talking really about Git. Git is a version control system. Probably a lot of you are familiar with it. And we are trying to see how projects use Git and how do they create different rules and patterns in their project for more efficient software development. Uh, so we are not going to go through Git basics, just to make it clear. But I think there are additional resources that probably talk about Git, or we can help you find some. All right, so why are we talking about Git workflows? We have many distributed teams, multiple people working on different parts of the code, and our goal many times is to collaborate in an effective manner, in a sustainable manner, and ensure that the software is being developed correctly, efficiently, and Git workflow can really help us in some of these goals. So let's start with centralized workflow. So the first thing to know about Git is that Git is a decentralized version control system, right? However, you can use Git in many ways and many patterns. And these patterns are called workflows. And the simplest pattern or simplest workflow is to use Git in a central way, where you have one central repo. This is very similar to subversion control, so SVN that was there way before Git. The idea is that you have one central repo, and everyone, and that repo is located somewhere on some server, and all the different users, they just check out that repo, create a local copy on their local machine, and then check in or whatever whenever they are done. Now in Git, the default development branch is called as a master. And whenever so when you create a Git repo, what you get is a master branch. And then when you check out stuff, do changes and commit back, you are essentially committing back your local modifications, you're committing it back to master. However, the issue arises when there are not like just 2 or 3 people, but there are many more people working on the same code. And some developers work on the code, work locally on their machine on features. They decide to commit every once in a while. Some commit every day, every minute, and so on. So when you have multiple people working on the same repo and on features that are in different stages of development, this definitely leads to code conflict and breaking of code, right? So it would be nice if you could work on another copy of the central repo itself. And that's where you start using Git in a more decentralized way, and the concepts of branches and pull requests and forks, they all play a role, and they all play a role in helping us organize or formulate a Git workflow and make our development process better. So there are many different ways in which you can use Git collaboration with multiple people. As I said, you have centralized workflow doesn't work well, but you have different workflow mechanisms such as branches, pull request, forks. And we will go through some of these things. But if you are familiar with the Git basics, you would be pretty familiar with these terms out here. So let's talk about branches out here. Branches are independent lines of development. A developer can essentially make a copy, which is called as a branch in Git terminology. So the developer can make a copy of the master and work on that branch, and other team members can do the same. The advantage of that is that if you break your branch during development, other people are not impacted, and your master branch is also not impacted and therefore protected. So eventually you will have to add your code changes to the master, so that the features of, whatever features you are working on, those are exposed to the main code and other team members. And when you are ready to, add those changes to the master, that concept is, the term is called as merging. So now you have a branch called master, and you can develop on a branch that you name as development or testing. And once your work is done, you merge the changes in your branch called development or branch called testing, you merge it to master. Now with Git, making branches is easy. It's very simple. You can create as many branches as you want. But when you're working on a project, you need to make good decision about, how many branches you want, what are the semantics of those branches, what are the names of those branches, what is the scope of work that will be done in those branches. So be careful about how much complexity you want to create in your branching system. You should aim to keep it reasonably simple so that a team with diverse Git expertise can use it productively. You don't want to make it so complicated that newer team members take a lot of ramp up time when it comes to using it. The good thing about Git is that there are a lot of complex branching models available for your team to use. So experienced users of Git can definitely take advantage of all this extra power that Git provides, uh, in order to make themselves more efficient. And newcomers can start with simpler things. So the entire team does not have to be aware of all the Git features that these experienced super users of Git that they are using. So let's talk about a special type of branch called feature branches. This is a feature, when you create a branch and you call it a feature branch, uh, that means that feature branches are created specifically for adding some feature to the code. And when that feature is completed, that branch is usually merged with the code, and then the branch can be deleted. So as I said, they are meant for special features. You can create a feature, you can have a feature branch that is created specifically for bug fixes. And this feature branch could be called as a bug fixing branch or a bug fixer and so on. So if you take a look at this example on the right-hand side, you see some snapshots, right? You have two people called Alice and Bob working on the same code. Alice creates a local branch from the master called add solver and starts making changes. And then Bob creates on his local machine, he checks out master and creates a branch called issue 151 for some issue that he's trying to fix. They create their branches at different times. So Alice is working on commit version C in the master. Bob is working on commit B of the master, and Alice makes changes D, E, F, G, I on her version, on her branch. Bob is doing something else like E, H, J changes on his branch. So they are the main repo. On the other hand, is still snapshotted at ABC. So this is showing how different people can work independently on their own look in their own local environment. Now let's see what happens when there's a feature branch diversion. So let's say Alice pushes her changes to master before Bob does. So now the master branch has C, D, F, G, I commits, which Bob's branch doesn't have. So when Bob wants to merge his branch, he has a conflict between his commit and the code in the master. So now he will have, this is called as a merge conflict. And Bob will now have to take some action or some additional steps to resolve this issue so that he can merge with the master successfully. And many times, when such things happen, there might be a feature race condition. So what is Bob going to do? Bob now has to rebase his commit. Rebasing his commit, like initially Bob's branch, if you remember, started at B. So he now needs to rebase his feature branch so that it will have all the changes made till commit I of the master. And if there are no conflicts in doing this rebase, then he can then merge his code and push them to master. and he can then choose to delete his branch once done. We won't go into the details of what is rebasing, how to do it. There are different methods in which you can do this merging and rebasing and resolving conflicts. So these come under the category of Git basics, and there's a lot of literature out there if this concept is new for you. So now we've been saying that branches, we talk about feature branches, and I've been saying that, hey, when the feature is done, you've merged, you can delete the branch. That's what usually happens. But there are other branches in the main repo that never get deleted or seem to at least have infinite lifetime. For example, your code may have branches called as production, development, pre-production, testing, and where you may have rules that production branch always should have stable code, whereas development branch may be work in progress. So each branch that you create provides a different environment, and that's a big advantage offered by Git. You can also set policies for your code and team. For example, you can say all feature branches must first be merged into a development branch, and they should be tested before being merged into a production branch. So these are what workflows are, saying, and with the help of policies saying that, listen, you can only work on the development branch, and then there's a path to go to the master or go to the production environment, and this branch can be stable, this is okay if it is unstable, and so on. So these rules and patterns are essentially Git workflows that we're talking about. So you can see that in this whatever picture, you can see that the add solver branch that Alice was working on, it didn't really get directly added. It was not merged into master directly, but merged after several commits to the development branch. Okay, quick look at pull request. Let's say that your team is working on a feature branch or any branch, and when that branch is ready to be merged, you create what is called as a pull request or a PR. A PR tells the owner of the code that there are changes being proposed. The PR, pull request, gets reviewed by the owner maintaining the code, and then the proposed changes are either accepted or rejected. Sometimes there may be discussions, negotiations, additional commits to that feature branch before the PR actually gets accepted into the main code or the master branch. You may even ask for a specific reviewer to review your PR. So you can say that, hey, code reviewer in my team, could you review this PR before I actually try to merge it in with the owner's approval. So pull requests essentially are a feature that makes it easier for developers to collaborate and establish trust. Let's talk about GitHub forks out here. So forks are a pretty important concept. A fork is essentially, it's a very common word. It essentially means creating a complete copy of a main repo inside another account. And this copy will include the master and all the branches that exist in that repo. One big advantage of fork is that you only need read access to the main repo and not write access. So let's say I want to contribute to open source project foo, and I can't write to foo. I can create a fork, for example, on GitHub, that will copy that entire foo thing in my local GitHub account, and then I can play around. I can work on it. My team can work on it. We could be serious contributors. And when we are done, if you would like to contribute to foo open source project, we just create a pull request, and we submit the pull request, and the repo owners, the original foo repo owners, can ensure that they're reviewing changes before accepting them to be added. This working model allows anyone in the public domain to become a full contributor to a code, while the main repo maintainer can ensure that only valid stuff gets accepted into the code. So a lot of open source projects have proliferated in our community over the world using this technique, where different public contributors have been instrumental in contributing code and contributing to the success of a software. So now we talk about GitHub, Git workflow models. So far we saw the centralized model, right? That where you just have one server and many copies are created and so on. And then we spoke about things like peer pull requests, feature branches, forks, and how they can help us. So now we're looking at more complex workflows. The first three listed here are Git flow, GitHub flow, and GitLab, and these are generic ideas. After this, we will discuss some specific examples of workflows used by popular software projects such as I think Trillinos and OpenMPI and so on. So Git flow is a branching model that emerged after Git emerged, it started becoming popular. That's when the Git flow branching model emerged. What is a branching model? So when you have a team, you want to ensure that each team member is following a set of steps so that you have a good and well-managed software development process. Git flow is one such branching model which tells what branch names are, what are the semantics of that branch name, so that everybody is consistent, so that everybody knows this is what I'm supposed to do. If I'm testing, this is what I'm supposed to do. If I'm working on a new feature, this is how I'm supposed to commit the code for pre-production and so on. To set of rules and policies and things in place to ensure people know what to do. Now, Git flow, this particular branching model is one such branching model that is very good for timed version software releases. And it's good if you maintain multiple versions of your software. So if you know that the version 1 of my software is going to release next month, version 2 is releasing 6 months later, and similarly every year we have 2 releases at this time. This is a pretty good workflow model for that. At its very core, Git flow branching model says that you should have 2 lifetime branches. And you can see them on the figure, maybe it's a little detailed. You have two lifetime branches, master and develop. Master is the production branch. When you start writing features, you will have your own feature branches, and merged to the they are all merged to this branch called the develop branch. So master and develop, any new features that you create eventually get merged to the develop branch. And when the source code in the develop branch reaches a stable point and it's ready to be released, all the changes should be merged to the master somehow and then tagged with the release number. Now, in addition to these feature branches that I spoke about, you could have hotfix branches, you could have release branches as well. So the Git flow basically, again, the pattern just says that everything that you write in your branches goes to develop branch first. If develop branch is good, then it goes to master. Now, one thing to again remember, and then I want to emphasize on, is technically everything is a branch. Master, develop, hotfixes, release, feature, they're all branches technically. They all have the same command to create them. But these are simply names given to branches, and they serve different purpose. So semantically, they serve different purpose. Technically, they are all created the same way. There's a good reference out here if you want to get more information about Git flow. So now the next workflow we want to talk about is the GitHub workflow. So this is an alternative to Git flow. The blog link out here, I think, has some pretty good information. It also talks about some of the limitations of the GitHub workflow. So this is considered a simpler Git workflow, and it's easier for people to pick up and start working with. It's very good for teams who have a culture of, pushing your code to production machines every day. If your team has a culture of constantly testing and deploying code, and some companies, for example, GitHub, that's why the name is GitHub Flow. Some companies like GitHub, that's what they kind of use this process. The rules for GitHub Flow are different. It says that anything in the master branch is deployable. So each team member has to be conscientious enough to ensure that they don't break master at all. It also says that feature branches can be created from master branches. I think there would be a policy which says that pull requests should be created early so that people can collaborate, so that people can review code, so as to not break master. And the merging of master has to be through PRs so that it can be reviewed. Uh, PRs have to pass testing before they can be merged, and that you need to deploy to master after the PR review, and you should deploy the master as soon as you need to merge into master after the PR review, and you need to deploy the master as soon as possible. So there are these certain rules that are associated with each kind of workflow. The third is GitLab workflow. And GitLab emerged because some people, some teams considered the features of Git flow and GitHub flow as, they thought they had too many limitations. For example, they didn't want to base feature branches off the develop branch, and they didn't want to synchronize various lifetime branches. They didn't want master to be automatically deployable and so on. So GitLab tries to combine feature-driven development and feature branches with issue tracking. So we don't have time to go through too many details, but this link out here, we try to put links that will be valuable to you. So go check that out. But the main idea in summary is that all features and fixes go to master. Master is considered staging, and that you have, from master, your code flows to two branches called production or pre-production. So master code goes to pre-production, everything is tested, then it goes to production. And bug fixes, hot fixes are made to master and then cherry picked from master to make its way into pre-production and other downstream branches. So, with this, we can, like with this three things, we can conclude that each of the workflows have their own space depending on the team requirements. And these are just three workflows that we have explored. You can create your own workflow, but if the requirements if your team requirements, project requirements kind of gel, then maybe you can pick up one of these workflows and get started with it. All right, very quickly, we are going to talk about some of the projects where we are actually using Git workflows. We talk about the Trilinos, OpenMPI, and the Flexi work projects. So in Trilinos, what is Trilinos? Trilinos software is essentially a collection of open source libraries, scientific libraries, mostly math libraries. And these libraries are used as building blocks to develop scientific applications. These libraries are, linear solvers and transient solvers and nonlinear solvers and so on. So when it comes to workflows, Trilinos has a test-driven workflow. You can go to this link out here to get more information. Trilinos, the workflow has feature branches that start and end with something called as a develop branch. All changes to the develop branch must come through pull requests. And once you create a pull request, that pull request goes through a test suite before it actually can go to develop after passing. So change sets from develop are usually tested for integration into master. So there's another level of testing. And everything in master is coming only from the develop branch. So therefore, there are no merge commits. If there are merge commits, they'll happen in the develop branch by itself and never while promoting to master. So that's the Trilinos workflow. Now, OpenMPI. OpenMPI is a popular MPI library, message passing interface library. If you work in scientific computing, high performance computing, you would have at least heard the word MPI. So what workflow does OpenMPI work? What workflow does OpenMPI use? So it's good to mention this workflow in this talk because it's unique in the sense that it supports two most recent releases. And as seen from the figure, there are branches named latest supported release and previous supported release. These two branches are always in a stable working condition. In addition, this workflow also says that the project should have a master branch and that any other branches such as upcoming releases and so on, if needed, they should exist. All the code development takes place in the master branch. And to ensure stability of the master branch, everything is submitted through PR. The PR has to be reviewed by the code reviewers on the team. And the master branch is always stable and in a working condition. A couple of important things to mention is about how branches can help facilitate improved testing. So in OpenMPI workflow, there are nightly tests running on all the branches. The team has also set up continuous integration testing to take place on all PRs on any branch using open source Jenkins automation system. Jenkins is an open source automation server. You might be familiar with it. It's pretty useful. Anyways, if you have additional branches or release candidate branches, you can fine tune your testing for those branches. Overall, the branches are organized, when branches are organized well, testing does become easier and more efficient. Okay, lastly, very quickly, we'll talk about the Flexi workflow. That's how I pronounce it. Flexi is a compile time configurable framework for helping with development of multi-physics applications. So the figure out here is kind of squished. It's not very complicated though. So the left, I can tell you a bit if you can't see the details, but the left hand column or column of circles that's a devel branch where the development takes place. The next column is called as, for the next middle column, it's called the it's called the version. It's called, in this example, it's called 1.x branch, which means that it's only meant for new releases. So whenever you have a new release coming up, you will create a 1.x branch, and all the 1.x branch related stuff will go in it. When you have a new release coming up after a year or whenever, and that new release will be 2.0, it'll again you'll again create a branch called 2.0 branch, which is coming from devel. I hope that makes sense. So based on the 1.x branch, one can have multiple release branches labeled as 1.0 release branch and 1.1 release branch. Each of the release branches can have tags which says 1.1.1 version of my software, 1.1.2 version of my software, and so on. And as I said, once you're done with the 1.x series of your software, and you then decide that this is going in maintenance mode and we are starting new software and new features in our software, and we want to call it 2.0, that's when 2.0 release branches get created. I also remember that this project has a special branch called GitLab CI. That is GitLab continuous integration to handle images, configuration files, so on. And similar to OpenMPI workflow, even this workflow ensures that all supported branches work at all time. All PRs are tested and reviewed, and it has customized. I think it has customized unit testing based on Google Test. So these are the three projects that are using workflows in different ways, and they're rich enough for you to get inspired by if you're not using workflows. So this is the last slide out here, and this talks about what are the considerations one should have for choosing a Git workflow. So you should have a clear set of policies. You have to ensure that there's a correct code somewhere in some branch, which is usually the master branch, but you have to make that clear. And the workflow should be easy for the team to communicate and be productive. It should not be heavyweight. Policies should be easy to learn and follow, and easy to enforce. See the culture of your team. See what they are comfortable with. What is the experience level of your team? What is the maturity of your project? And then decide, and avoid the temptation to go with a highly complex workflow when your needs can be met by a simpler one. Have a document with all the policies and make it clear. So these are the considerations you should choose. This is the last slide. And I think with this, I can conclude the presentation. There are some demo slides, but we're not going to go through that. Any questions?